This is section 8, implicit differentiation, example 3. So just like you can take higher order derivatives using any other explicit differentiation, that's what it's actually called. We just don't use those words most of the time. We just call it differentiation. You can take a higher order derivative using implicit differentiation, and it's going to be a tiny, tiny, tiny different, but it'll still make sense eventually. Okay, I promise. So for part A, we are going to do the implicit differentiation like we did before. So we take the 2, move it to the front, so we get 2x dx dx plus 2y dy dx equals 0. We know that dx dx is just 1, so when we're trying to get dy dx by itself, we move the 2x to the other side, so 2y dy dx equals negative 2y. We divide, I'm sorry, that's x. That's negative 2x. We divide by 2y, so dy dx equals negative 2x over 2y, which simplifies to negative x over y. Now, that's the first derivative. Now we need to find d squared y over dx squared, which means we need to find the second derivative, which means we're taking the derivative of that. Now, x and y are both functions, so we are going to have to use the quotient rule, right, because they're divided, and we're going to have to make sure to include the derivatives of each function. So, d squared y over dx squared. We have low d high, so y times negative dx dx minus high d low, so negative x times dy dx over low low, which is just y squared. Now we do need to simplify. It's very, very important that we simplify. Okay, we know that dx dx is 1. The negatives become positive. So we end up with negative y plus x dy dx over y squared. Now it looks like, hey, you'd be done, right? Wrong. We're wrong because dy dx cannot be a part of our answer. That doesn't make any sense. And the reason it doesn't make any sense is because we know what dy dx is. Dy dx is negative x over y. So we're actually going to take this and plug it in right there. So we end up with negative y plus x times negative x over y squared. Now that's not very pretty. Not at all. So the only way to make this prettier would be to multiply everything by y. And we would do that to get rid of the denominator. If I multiply every term by y, then suddenly that's times y, that's times y, and that's times y. Then now I have negative y squared. That y cancels that y, making this negative x squared over y cubed. That's the prettiest form it's going to be in. And while you don't have to do that for a free response question, if this were given in a multiple choice question, that's how it's going to look. Okay, so you need to know how to do that. Let's do another one. Y squared equals 9x. Hey, this one might be a little bit easier. All right, so we have 2y dy dx equals 9 dx dx. Well, dx dx is 1. So to get dy dx by itself, I would just divide. So dy dx is 9 over 2y. Okay, well, if I want to make this really easy on myself, I can just move that y to the top. Okay, so I really have 9 halves y to the negative first power, which is going to make this easier to differentiate. So, second derivative would mean taking the negative 1, moving it to the front, so we have negative 9 halves y to the negative second power times dy dx. All right, that means that we actually have negative, and I'm going to go ahead and make this prettier, 9 over 2y squared, and I cannot leave this the way it is. I have to take this 9 over 2y and put it in there. so it's times 9 over 2y. Now I'm going to simplify even further, so we get negative 81 over 2 times 2 is 4y cubed. That's the answer.